Function composition. This is the last method of combining functions that we're going to look at. So a composite function is when you form a new function from two functions, f and g. So where the output of one function is the input of the other. So we're going to look at f of g, which means the same thing as f of g. And what we're doing is we're putting x into the inside function first, getting an answer, and taking the output and putting it into the outside function. So you start from the inside, evaluate that function, and put your answer into the new one. So that's how the output of g of x becomes the input of f of x. Let's take some examples to make sense of this. We're going to calculate f of g of 2. Recommend you write it this way, and then we always start from the inside. So our first job is to calculate g of 2. Now, let's remember what our functions are. F of x is x squared, g of x is 2x plus 2. So if you were calculating g of 2, what you've just done is let x equal 2. So this x is also equal to 2. So the answer for g of 2 is 4 plus 1, which is 5. So g of 2 becomes 5. We then calculate f of 5. To calculate f of 5, you're replacing x with 5. And so we get 5 squared. So that answer is 25. So let's just look at that again. F of g of 2, we write f of g of 2. We start from the inside. To calculate g of 2, you're evaluating your g function when x is 2. So g of 2 is the same thing as 5. G of 2 is equal to 5. Then we're calculating f of 5, which is evaluating the f function when x is 5. Another way to think of it, if you don't like my notation so far, is you're calculating the y value for f of x when x is 5. So when x is 5, you would get a value of 25. And this is the answer for what y equals. Let's try another one. F of g of negative 1. To calculate g of negative 1, we're evaluating the g function when x is negative 1. So that would equal 2 times negative 1 plus 1. Where is that negative 1 coming from? We said x was equal to negative 1. So negative 2 plus 1, g of negative 1 then is equal to negative 1. So g of negative 1 is going to get replaced with negative 1 because g of negative 1 equals negative 1. Now you're calculating f of negative 1, which means evaluating the f function when x is equal to negative 1. You're taking negative 1 and you're squaring it. The answer for negative 1 squared is 1. G of f of negative 2. That's different from f of g. So what's the outside function and what's the inside function? Outside function is g, inside function is f. So this time we start with f. You're going to calculate f of negative 2. Calculating f of negative 2. We're putting negative 2 in for x. We're taking negative 2 and we're squaring it. The answer for that one should be 4. So f of negative 2 is going to get replaced with 4. Now we're calculating g of 4. Go to your g function. G of 4, you're replacing x with 4. We'd have 2 times 4 plus 1. That would give us 8 plus 1. Final answer for that should be 9. Let's try 3 more. G of f of 1. Start by rewriting it. Outside function is g, inside function is f. Always start from the inside. Calculate f of 1. To calculate f of 1, you're putting 1 in for x. 1 squared would be 1. So I'm replacing f of 1 with 1. Now I'm calculating g of 1. G of 1, we're putting 1 in for x in the g function. And when we do that, 2 times 1 plus 1, we should get an answer of 3. F of 2. Huh, that's different. Doesn't matter. That's the same letter. Let's try it. F of 2. So we have to start with the f function. So you start by calculating f of 2. Calculating f of 2, we're going to put 2 in for x. So that should give us an answer of 4 for f of 2. And then we go back to the f function. All right. So now we're calculating f of 4. So we're putting 4 in and squaring it. So final answer for that one should be 16. So what happened there, instead of going into g of x and then f of x, we went into f of x and then f of x again. Interesting. What's going on here? G of 3. All right, so we're calculating g of 3. So we're doing very much like what we did with the f function, but this time with the g function. So this time we're going into g of x and then into g of x again. Okay, g of 3. Put 3 in for every x. We'll get 2 times 3 plus 1. So g of 3 is going to equal 7. So for g of 3, we get an answer of 7. And now we're going to calculate g of 7. So we go back to the g function. Put 7 in for x. So 2 times 7 plus 1. The answer for that should be 14. Plus 1 is 15. Right. So 2 times 7 plus 1. Okay, we can do the same thing just by looking at graphs. So I've hidden the functions for you. I'm not telling you what f and g are. We're going to do it from the graph. Won't this be fun? Okay, the first one we're doing is f of g of 0. So I've got this line, and we're going to move it to an x value of 0. G is the red function. So where does the black line intersect the red function? Right here. So this is the point 0, 1. So g of 0 is saying, what is the y value when x is 0? And the answer is 1. So again, what just happened? G of 0. Go to where x is equal to 0. Find out where it intersects the g function and read off the y value. So g of 0 is the same as 1. Now we're doing f of 1. So the x value is 1. We have to go to an x value of 1. We're intersecting with the f function, which is the green one. So the green one is f. Crosses at what y value? -3. So the answer for f of 1 is -3. Let's just back up and do that again. If you know what you're doing, feel free to do the next 3 ahead of me. We started by doing the inside function, g of 0. G of 0 says your x value is 0, what's your y? Your y value is 1. Then we're doing f of 1. That says the x value is 1. What's your y value on the green graph this time? Because now we're calculating f. Okay, let's try this one. G of -1. If we're going to do g of -1, we need an x value of -1. Where does that intersect the g function? At a y value of 0. So g of -1 is equal to 0. Now we're calculating the value of f at 0. So the x value must equal 0. There's our x value of 0. Where did it cross the green graph? Looks to be -4 to me. So f of 0 is -4. It's just another way of evaluating functions. G of -2. There's an x value of -2. Where does it cross the red graph? At -3. So g of -2 is -3. G of -2 is -3. G of -2 is -3. F of -3. We need an x value of -3. We want to know where it intersected with the green graph. Looks to be at -7 to me. So f of -3 is -7. One more. See if you can do this on your own. F of 0. Let's go to 0. F of 0, where does it intersect the green graph? Looks to be at -4 to me. So f of 0, what is the y value on the green graph when x is 0? The y value is -4. Now we're finding f of -4. When x is -4, what is the y value on the f graph? -8. So final answer for that, -8. So it's doing exactly what we did on the previous slide. We just don't know the equation anymore. Now, if it upsets you too much, I have the equations here. We can double check. G of 0, 1 minus 0, that's 1. F of 1, 1 minus 4 is -3. So you can see it really is doing the exact same thing we did on the previous slide. We're just doing it from the graph this time. Okay, more fun things you can do. We're going to be given two functions, f of x equals x squared minus 1, g of x equals x minus 8. We're going to calculate f of g of x. All right, I think I'd like another way of writing f of g of x. F of g of x. Okay, so we know we start with the inside function. The inside function is root x minus 8. So I'm going to replace g of x with root x minus 8. Not so bad. Starting with the inside function, replacing it with what it's equal to. Now we're going to calculate f of that. So we're calculating f of root x minus 8. So x is being replaced with root x minus 8. So what happens on the other side? It becomes root x minus 8 squared minus 1. So all we're doing is replacing this x with root x minus 8. So it becomes root x minus 8 squared minus 1. When you square a radical, we're allowed to get rid of the radical. We get x minus 8 minus 1, which gives us x minus 9. So there's the equation. We're going to graph it next. And if anyone is copying notes at this point, I'd put your pencil down. I have a feeling we're about to make an interesting mistake. X minus 9 is the y equal x graph shifted down 9. So it's going to cross at -9 and 9. And we're going to draw ourselves this graph. And everything looks good at the moment. It's a pretty awful straight line, but you get the idea. And we're tempted to say that's our answer. And then we'll calculate domain and range, and it looks like the reals. And we're wrong. Where did we go wrong? I'll tell you, we're right up until here. So what we have to keep in mind is you're putting x into the g of x function first. G of x is the inside function. Are there any restrictions on the g of x function? Is there anything that x is not allowed to equal? And I believe root x minus 8, we would need x to be bigger than or equal to 8. Otherwise, we're going to get complex numbers, and we're not interested in those. So our real domain is x bigger than or equal to 8, which means part of this graph should not be there. So let's see if we can just erase that. Okay, and let's draw ourselves a new graph now. So you just have to be a little bit careful when you draw these graphs. we had to start greater than or equal to 8. So this is where our graph starts. So this is actually the correct answer for the graph. And we would never have known that if we just looked at the final answer. So you have to be very, very careful with function composition. You must exist for the first function, or there's no way you can exist for the function composition. If x isn't allowed to get in here, nothing will come out and we'll get no answer. Now, where did that range come from? When we look at the graph, when we start at 8, we see that the y value starts at -1. So be careful. When you graph function composition, you have to make sure that your domain exists for the first function and then for your final answer. So we always have to check the first function or the inside function and then the final answer. Let's try another one. G of f of x. Okay, so we'll rewrite that one. G of f of x. And f of x in this case is x squared minus 1. So we simply replaced f of x with x squared minus 1. Now we're calculating g of x squared minus 1. So instead of x, we're putting x squared minus 1 up here. So this x also gets replaced with x squared minus 1. And if you're confused at this, think about it. If you calculate g of 5, you put 5 in for x. G of 10, put 10 in for x. G of anything, put anything in for x. G of x squared minus 1, put x squared minus 1 in for x. We'll clean that up. And now the graph of this. This is fun. We're going to be doing a lot of this in the next section, but I'll give you a preview right now. First, you start with the inside function, x squared minus 9. Then we're going to take the square root. This is marvelous. Can you take a square root of these negative numbers? Nope. So that entire section of the graph is gone. Then I want you to think about numbers that are easy to find square roots of. 0 is an easy number to find the square root of. When you take the square root of 0, you get 0. So that point and that point are going to stay in the same place. Let's see if I can draw you a very rough graph. So the point that was at 3, 0 and -3, 0, they stay there. Other numbers that are easy to find square roots of are 1. So this point will also stay in the same place. So we have another point somewhere up here. This is very rough. Easy number to find the square root of, 4. This will drop down to 2. So the number that was at 4 is going to drop down to 2. Wow, I wonder what that graph's going to look like. Another easy one would be 9. That would drop down to 3. So the nice looking version is this. Isn't that beautiful? So why is there nothing in here? Because we can't take the square root of a negative. Why did it drop down like this? When you had the square root of 4, it came down to 2. When you had the square root of 9, it came down to 3. So that's where we're getting all these points from. Let's keep going. Domain and range. Start with the inside one. Do we have any restrictions on the inside function? Is there anything we're not allowed to put in here? No, that one has no restrictions. So far we're good. Now let's look at the final answer. Are there any restrictions? Oh yes. It doesn't exist between -3 and 3. So where does it exist? This would start at -infinity and go to -3. Which is the same as saying x less than or equal to -3. And this section would start at 3 and go to infinity, which is the same as saying x is greater than or equal to 3. What's your range? What y values are included in our graph? I don't see anything below here, so just values above the x-axis. So that would be y greater than or equal to 0. Ooh, these are interesting. So again, when you check for domain and range, you must check the inside function for restrictions and then the final answer for restrictions. If anyone's worried about how to get this graph, we're going to do more of that in the next video, so don't panic. Okay, one more. I'm afraid I gave you some hints down here. Y equals x squared minus 1 is the first function, and g of x equals root x minus 8 is the next function. We're finding f of x. So let's start with the inside function. f of x. Okay, inside function is x squared minus 1. So we'll replace this with x squared minus 1. Now we're calculating f of x squared minus 1. So instead of x, we're putting in x squared minus 1. So f of x squared minus 1 becomes x squared minus 1 squared minus 1. Whew. Okay, we're going to square x squared minus 1. For those who need the box, you do it this way. We'd have x squared minus 1 multiplied by x squared minus 1. What does that give us? X to the 4th minus x squared minus another x squared plus 1. Okay, so there's our x to the 4th minus x squared plus 1, and then we had another minus 1. Cleans up to this. Now, graphing that's a polynomial. Polynomials you often graph by factoring. There's a common factor of x squared that we'll pull out. Double check, x squared times x squared is x to the 4th. X squared times minus 2 is minus 2x squared. We find x-intercepts. There's 2 at 0. And what makes x squared minus 2 equals 0? X squared minus 2 equals 0. So that would be x squared equals 2. What makes x squared equal 2 could be plus or minus root 2. Y-intercept, if x is 0, y must be 0. Another way to find it, plug 0 in here. And degree is the highest power of x. Ooh, this is a good reminder. Do you remember what the graph looks like? We would have an x-intercept of 0 and another x-intercept of 0. An x-intercept of root 2, that's 1.414. And negative. Degree, even, starts here, ends here. So our graph, go through there. What happens when there's 2? There should be a bounce and come through there. So there's our final graph. Now let's talk about domain and range. Domain, start with the inside function. Are there any restrictions on this? Is there anything that x cannot equal? No, I think we're good. What about the final answer? Is there anything that x cannot equal? Polynomials are defined for all values of x. So I think on that one, domain and range are the reals. So when you do function composition, sometimes the inside function has restrictions. Sometimes the final answer has restrictions. And sometimes there are no restrictions. Okay, your job today, 1 to 4. Function composition is really quite important. It's good for you to be able to recognize when we're using it. It will be important in calculus. So get comfortable with this today. And as always, have fun.